Hey guys, this is Abhishek and I hope you are able to do all of these exercises, which was very similar to all the list related operations which I showed you, except one thing, which is the last exercise: multiply the list with 2 and see its output. So our list was the number of games. So let's say I'm in a new session. So what I'll do is I will just define one simple list: hockey, and then cricket, then football, and then finally maybe baseball. Alright, so once we are here, what we can do is once we execute this, I'll just create some space and say games multiply with 2. So what is happening over here is hockey, cricket, football and baseball, right up till here. What we are having again the list. So what it is doing when you multiply it with 2, it creates the duplicate elements within the same list. Similarly, if we have let's say numeric information, maybe 5, 8, 10, 15, okay, and I multiply it, what it does is 5, 8, 10, 15, and after that again 5, 10, 5, 8, 10 and 15. It means dual elements. So what we may expect in such cases that whenever we are doing a multiplication, ideally it should multiply the values by 2, or whatever mathematical operation, maybe divide or addition or subtraction, all of that. So that's where the NumPy arrays comes into the picture. So NumPy arrays efficiently do the data processing. That's like the base library for doing the data processing to manage the numerical data, and you can even apply the statistical function like average, like mean, median, mode, or standard deviation, square root, all of those things. So let's see how we can really do the basic operations within the NumPy to understand it. So first thing is importing the NumPy as NP, import NumPy as NP. Once we execute this, let's create a single list. Maybe what you can consider is the number of goals that were made in one season by one team. So maybe in the game of football or hockey, whatever you can. So scores is this, right? What we are doing over here in the third line after creating this list, so to first of all see whether it is list or not, you may remember that we can use the type function. So if I create one new cell and say type scores, it gives us list, and if I multiply it by 2 or do any operation, it will duplicate the elements. So what we need to do in such cases where we want to process the numerical information present in the list is convert it into a NumPy array. So to convert into a NumPy array, what we do is use a function np.array and then pass the parameter as the list. So what it does is it creates the NumPy array from the list, and we have stored the result into np_scores. Okay, so if I execute this, right, nothing will come out because we have not printed anything. Now what I do is type the np_scores. So scores is list. Now we have used the np.array function, then it has become the numpy.ndArray, right? So this is now ready for doing any sort of data processing. Alright, let's move on. So first of all, let's print to see the difference between the list. So 32051 is what we are getting when we are printing it within that brackets. But now let's go ahead and do the addition, right? So print np_scores plus 2. First of all, what you can do is take a pause and guess what this operation is going to do and then hit it. Alright, so now let's execute this. So what it has done, in each element it has added 2. So 3 plus 2 5, 2 plus 2 4, 0 plus 2 2, 5 plus 2 is this. Similarly, if I want, I can change this and print it. Now 3 multiplied by 2 is 6, 2 multiplied by 2 is 4, and that's what our desired expectation or the outcome is, that whenever we are doing any addition, multiplication or any arithmetic operation, then it should do the same behavior. Similarly, if I use double asterisk, I hope you remember this. So what it does, it gives you the power. So 3 multiplied by 3, or 3 is to the power 2. So if I execute this, when 3 is to the power 2, it's like 9. 2 to the power 2 is 4. 0 will be 0. 5 5 25. 2 and 2 4. 1 multiplied 1 1. Similarly, if I give 3, it's like cube, right? So this sort of operation, this is like a power operation. You know, it gives the power based on the number that you are specifying. All right, let's move on and now see the shape. So there is a one-dimensional array, there is two-dimensional array, and all of that. But what we can do is get the number of elements by row and column. So this basically indicates the number of elements and have a comma. If it is a multi-dimensional array, then we would have the second value as well. So I've already shown you this particular operation, so I'm not going to show it again. What I'll do is I will now use the statistical function, which is average, and represented by .mean. So what we want to do is the value which are stored in the np underscore scores, we want to take a mean or the average of all the values. So np underscore scores dot mean, the value will be 2.16. Similarly, if you have any other big array and you want to take an average, very easily you can use this. So that's one way of doing it. Another way is you can just first of all get the library and then use the mean, and if you want to store the values, in that case you can do that. Similarly, np.sum to sum all the values. If you just do not want to take an average but want to sum, or you want both the things, then you can do that. Similarly, there is a median and average. The mean should be similar. So if you go median, mean is 2.16 and median is 2. There is a slight difference between mean and median, and as per the theory, median is helpful in those scenarios where there are no extreme values. So what it does is it first of all does the order into the data in ascending and find out the middle value by looking at the element placed, whereas mean basically sum all the values and divide by the number of values. So what it does is it also if you have any high or low values, it will either inflate or deflate your results. So sometimes median is a better representation than mean in case of the outliers. Alright, let's go ahead and use another function, which is STD, standard deviation, which is 1.57. So that's pretty standard or straightforward about how you can do the apply the statistical function. Now let's create another one, which is a new score. Maybe that's the new score that you have in the new season, right? So we create a new score, and now what we are doing is we are creating a multi-dimensional array. That means it. So let me just create and show it to you. So multi-score, what we have done is within the bracket we have taken the first score and the new score and created a new score, which is multi-score. If I show you the multi-score, it is basically your right now two lists within one single list, right? So what we can do, as always, we can use the np.array function that we used earlier and create it into a multi-dimensional array. If I show you the multi-dimensional array, then you have the array, and here is my first list or the score from the previous sessions, and here I have the scores from the current session. And now I can do the slice and dice let's say if I want to select only the first session and second session, and if I have, let's say, 10, 15, 100 different sessions and I'm doing a data processing, I can create this array or keep on adding to the array and do the data processing. But the important thing is that you should know how to slice and dice. So let's see that thing. So m_array 0. So this indicates row, and this indicates column. So this is a row, row 1, row 2, and if you remember from our list video, our indexing starts from 0. So 0 is first row, 1 is second row. So take a pause and think what this will give you a return. Alright, let's execute this. 0 indicates, as I mentioned, the first row. So it has given us the first row. And if I want, I can then apply any statistical function like .mean or anything, or at the start np.mean. And I want the average of first basically list. So I can do that like this. Second is m_array 1. Again, take a pause and think what it will return. Alright, let's execute this. So it has returned the second, because 0, 1, 1 is your basically index number, but row is second. Alright, and now let's see what this will return. Now if you see, before the comma the value is not present, but after the 1 the comma is present, and what it indicates, the row and column. So take a pause and think about it, but it will be a little wrong. So let's execute this. So it will give you an error. What you might have expected, that it should give you the first column, but it has not. So that's the way we need to understand that if we want the value from the first column, what we need to specify is the column to indicate that we need all the rows, right? We need all the rows, but only the first column. So let's execute this. Now what it has returned is array 2, 4. Right? If I go up a little bit here, let me, so at first position 0, 1. At first position we have asked the value from both the rows. So we have 1, at 0 position we have 2, at first position we have 4. So 0 and 1, 2 and 4 is what it has been returned by this particular operation. Alright. Similarly, like I mentioned, you can apply the statistical function on the first row. So if you remember from our previous operation where we had just the one array, the mean was 2.16, and when we are indicating 0, we are saying that give us the value from the first session, right? If we change it to 1, it will change the value and say 2.83. That means in the second season our score was improved. Alright, after that I want you to take a pause again on this video and think about what it should return. So what you can do is, what I'll do is I will just print the array m_array. Now think what it should return. 1, 0. So 1 is basically a row and 0 is basically your columns, row and column. Think what it should return, and if I go ahead and execute this, it will return 2. So think about it, why it has returned a value like this, and if you have guessed it right, then pretty much you have mastered this basics of array. Alright, so what I'll do is I will end this session with the exercise so that you can better understand this concept. And what I want you to do is create an array np_matches from the list of matches. Matches is equals to 3, 6, 4, 2, 5, 2. You can consider this as the number of matches that has been played by a particular team in the game, and then print the type of new created array. Third question is access the fourth element of the array, and then access all the elements until fourth array. That's a point you need to grasp, that you need to return until fourth array. Then access all the elements from fourth till end. Then create another list scores is equals to 350, 700, 550, 320, 610 and 250. So that is a score that has been created in each match. Well, this is possible in the game of cricket, so that's the example I have taken, and that's pretty much possible in the test matches, which is a 5-day match between two teams. So that's the score that has been created. Now what you do is create a multi-list match underscore scores from the matches and scores list. And after that, you need to create a 2-dimensional array np underscore matches underscore scores from this multi-list matches underscore scores. So if I just give you the space over here. Alright. After you have created this after you have created the 2D array, what you can do is you can print the first row of the 2D array, then print the third column of 2D array. So this requires slicing and dicing of elements. After that, you need to identify what is the highest and lowest score from this array, and then what is the average score in that season when all the matches were played. After that, what is the total score in the season, and then finally what is the score in the last match. So if you identify the answer of all of these questions which was asked by your management, then you are all good with the basics of array, and think like you have mastered the art of slicing and dicing and then applying the statistical function to aggregate the values and give the answers of question like these. Alright, so I hope you will enjoy these exercises, and I will meet you in the new video.